So hello everybody. So as I said yesterday, I have updated the code samples and put them online. The link is slightly different because the link I gave you yesterday was Monadic Party 2018 sample. This one has samples. The first one that I was showing you yesterday is in it's numbered as sample number 1. So let's return to it. So now if you check it out, there are 4 samples. The first one contains the I don't know if you can see it. Yeah, I'm trying. Oh. Can I? Yes. Once Discord boots up.
That's really not obvious. Okay, you figured it out. Do you start it now?
Yeah. So yeah. Okay, now how do I zoom in? Okay. So can everybody see the code? Now let me just toggle panel. Okay, this should be. So if we go back to the first sample I showed you yesterday. So there are some additional things I would like to show you. So first of all, the runtime provides lots of serialization and deserialization mechanism out of the box. So here we, for instance, here we will define a type. So this is an F# type, but that's essentially equivalent to Haskell record. There is an annotation here to give it a default constructor, meaning that you can construct a type of person with default values, which is used for serialization and deserialization. And then we can actually define an HTTP trigger that takes a person as an argument. And what this will give us is that we can actually send a request to this function, providing it with a JSON representation of that person, and the runtime will handle serialization and deserialization automatically for us. So to give you an example, so if we go to this sample, if we do, okay, so is that readable? So if we do .NET build, oh, and before I started, I have the storage emulator running in the background. So you can start it by using the Azure command. Now, if you start the storage emulator, it will sort of put its intermediate files in the directory you started, or you can give it a predefined location. So if you just want to put all the files in a temporary directory, you can do Azure-L $temp there, which in most Linux and Mac OS systems should point to a temporary directory in your temp there. So for instance, in my case, it's yeah, Mac OS puts temporary in var, but on Linux it'll be somewhere in temp. So we have emulator running, and now we can start the function host. So this function host found 3 functions. 3 functions that we sort of talked about yesterday. So one, which is a simple HTTP endpoint. Second one, which is a function that will return a message that will not get returned as a part of a request, but it will be in this case it will be serialized and put on a queue. So the syntax is slightly different than I said yesterday, because we need to annotate the return type. So for those of you in Haskell we can write the type definition on a separate line. F# and ML languages are sort of slightly difficult with the regard that you need to write type annotations in line. So we have a function foo, which takes an argument person, which takes a trace writer as a second argument, and it returns something that's annotated with a queue attribute, and we'll put it on a sample queue. And the inference tells us that it will take a person and trace writer and return another person. So let's send something to the first endpoint. So if I curl it with nothing, okay, wrong one. This one. If I curl it with no data, it returns hello, an empty string, because the runtime for the purpose of serialization and automatic serialization and deserialization, runtime stacks default values in there. For the purpose of string, the default value is an empty string, and then it either that or it shoves null in it, and the print format is smart enough to handle null strings. Anyways, if we supply it with some data in JSON format, it will deserialize it to something we can work with. What name should I give it? What's your name?
Martin.
Okay, so in this case it will we send a JSON representation that corresponds to the person, and it gets automatically deserialized by the runtime and handled for us. Now, it's really cool for prototyping, but there are some drawbacks to that. Namely, because the serialization and deserialization is handled by the runtime, we cannot intercept it in case of failure. Now, I'll try to break it now. I'm not sure if the serializer is smart enough to handle it, but if we give it some malformed data, then it will probably complain. Oh, so it doesn't complain, but it doesn't deserialize it properly, and we don't really know if anything went wrong. So this way of doing things is extremely cool for prototyping, especially if you you don't deal with any user-defined input and you only work with sort of input produced or consumed by your libraries or services in a way that you have pretty good, you're pretty confident that the input is properly formed. Of course, the moment you try to do anything serious, you always need to make sure that you sanitize your inputs and handle them properly, because you don't want to you don't want to work with 1,000 lines of code, or even worse, 1,000 lines of Haskell code that sort of starts to behave in a really weird way because there was a missing comma somewhere. So, yeah.
What would happen if we had a personal container, let's say field age of type integer or something, and you pass non-integer there? Would it still?
So now,
because
okay, it's a good question. We can try that with a string. I'm not sure if it will interpolate it to something non-stringy, and we can see. So say if I try to, I'll try to give it. So now we're sort of entering default sort of. So int it will translate for. Let's try doing it for int. So I need to shut it down. I'll give person an age of type int.
I'm just wondering if it's possible to crash this function.
So it's definitely possible to crash the function in such a way. It will not crash the runtime. Because it will simply report an exception, and in that, so I think if we do this and we, so if we do, so now, so say we do, now why is this complaining about, oh yeah, this needs to be. So if we build that and run it, so okay. So the library the runtime is using is called JSON.NET. It's so the behavior you see now is guided by the default behavior in JSON.NET. I believe you can update the config to match your own needs. Say that it should fail on every error, not just sort of fail silently and provide the default value. So we build it. Let's start it. So if we don't give it an age, I believe it will get the default value for int, which is 0. And if we give a malformed age, by default it will. You're not 70, right? It will, yeah. It will crash the function, but it will not crash the runtime. You can still, once you give it a proper input, it will continue to work. The nice thing about it is once you deploy, you'll be able to see those exceptions in your log. So that's HTTP endpoint. And the thing I mentioned to you about queues yesterday is that if we send a message about Martin to the queue endpoint, yeah, I did something horrible. So we do. So here we don't get any reply because the result of that function got serialized as a message on the queue. And if we inspect the log, we see that that we executed the function that was so we start executing the function sample queue producer, and the reason is that somebody called an endpoint and received a message about Martin, and once we finished executing it, next function gets called because that function was waiting for a message on the sample queue. And indeed, that function received a message about Martin. So this tool becomes extremely powerful when you're prototyping or just playing around with a topology of functions, because you don't need to provision those queues, you don't need to handle them, you don't need to worry about them, and as I said before, it will actually handle failure in a graceful way. So for instance, if we were to by accident put a malformed message about a person on a queue, and another function would fail to deserialize it, the message will still be in the queue, and the runtime will try doing it 5 times. Then it will move to a poison queue. So we'll sort of deallocate. I mean, it'll remove the message that was causing trouble and put in a different queue, which is extremely useful in both prototyping and actual production, because once you get a misbehaving function, it will not sort of tear your whole system down. So now, how do you think one would be able to run Haskell in this setting? Any ideas? So I have a runtime that doesn't support Haskell. What's the easiest way to run a Haskell code? Or rather, what's the default way of running Haskell code on any operating system?
Creating an executable.
Yeah. You either use GHCI or you build an executable. So let's go to the second sample. This is not an Azure function project yet. This is a simple F# project that I'll show you how to run different executable in it and sort of intercept input and output. But I'll also show you an interesting trick which was sort of missed earlier. So I'm using Stack. So Stack is really nice because it sort of gives you reproducible builds and gives you slightly more control about what you're doing. And one interesting thing that Stack allows you to do, it allows you to specify your local bin path where it will put binaries that you built in this project. By default, it's in your home directory .local.bin, I believe.
Home directory local bin.
Yeah, that's the default one. So when you do stack install something, it'll put executable there. But actually, this setting you can set it up per project. So in this way, we'll set it up to the local directory bin in our project. So whenever we build our Haskell executable, it will be put inside the project directory. So let me just close these windows. So this is our Haskell executable. It just that prints hello world because we just want to see how we can run it. Sorry. And in this case, our F# code is slightly more complicated. Because what essentially we're doing, we'll be using the functionality within .NET to run a separate process, and we will read whatever it's writing on standard output, wait for it to exit, and then print whatever we received from it. Yep.
Use Haskell to create a new process that.
Oh, yeah.
That code does.
So this is F# syntax. So essentially, have you used Python or Java?
Java.
So Java has a using syntax for streams that you sort of enter a block and close the stream once you leave the block, if I remember correctly. So that's for handling resources. That's the same syntax in F#. This allocates the resources for a process, and the moment you leave the scope of this use block, it will deallocate the resources. So this is, in a way, it's just a variable binding, but the variable binding is once you leave the scope, it will sort of free the resources. So that's one. So in .NET. So .NET is a garbage collected language, but for some resources you don't want to wait for garbage collector to sort of stick around and figure out that the resource is not needed anymore. For that we use they use this sort of use blocks that the moment you leave a part of your code that you know that you don't need the resources anymore, then you sort of free it and don't wait for the garbage collector. Okay. So I'm not gonna explain everything in here because that's sort of more C#, F# code. But essentially, we start the process and we sort of capture standard output. So if I do stack install, which will build our executable. Here I called it foo, and it will install the executable in our current directory bin. And by default, stack complains that oh, you wanted me to install something, but that path is not in your system path. So if I were to type in foo, I will not be able to run it. But since I know where it is, I can always run it. So if I run it directly, it just types in hello world. If I run my .NET project I have here, it finds the executable, which is hard-coded in the code, and runs it, gets the output, and finishes execution. So that's enough for running Haskell executable. But how would you be able to communicate with it? Any ideas?
It runs the streams, you can attach to them.
Yeah, so one way is communicating via input-output streams. What are the other possibilities? So input and output stream are one way of doing it. There's one other thing that Unix allows you to do. Yeah, I think they're called, so the name I found were sort of named pipes or domain sockets. So essentially, there are file-like things in Unix for inter-process communication. And thankfully, both .NET and Haskell support them. So we can create one on the .NET side and communicate with Haskell side. So that will get
What's the name?
Unix domain sockets. And
Domain sockets.
yes, so it's a normal socket sort of used to communicate between different machines. So you need to have an IP address or a port. And domain socket looks like a file. So it's just a file in your system that you can write to it and read to it. It's not a full file, because I don't think it's if I remember correctly, it's not fully persisted. And if you start writing a lot of it, at one point it will block because it expects another party to start reading from it.
So it's like a queue.
So whenever you so I believe Unix does it whenever you do this or something similar. So it's essentially trying to replicate this behavior. So .NET actually calls them named pipes because this is a pipe that you can refer to it as a name. And next sample will be a bit hacky because .NET does not give you sort of direct named pipe interface. It only gives you an abstraction over it, which sort of works in terms of client and server model. That whenever you would, I mean, they expect you that whenever you write a .NET application, you just have a server that gives a name to your socket, and then multiple .NET clients connect to it. But it uses domain sockets, so we can sort of so it works with Haskell. So here, if we go to our third sample, and now this is way more complicated. So I'll start by having a helper function, because whenever you create a named pipe in .NET, what it actually does, it creates it in your tempter, and it gives the prefix corefx pipe underscore and the name of the pipe. So we will create an input socket, an output socket. We will get a path to our current directory. This time, for the third sample, I named the executable bar to make sure that they don't conflict with each other, and I'll print out for debugging purposes the path to input and output socket, and then I prepare the process to start. Now, here I'll give a socket a predefined name, but the problem is that the tempter is fixed per session. So if I were to run multiple processes or multiple instances of my solution, they will collide. So later I'll be able to sort of specify or generate the name for input and output socket. So I need to have a way to tell Haskell executable where to look for those sockets. And there are multiple ways of doing that. And I believe the current Unixy way of finding those is by by extending the environment of the child process with a variable name, with a variable for input and output socket, and giving it a path. Everybody follow so far?
There's 6 those 2 environment variables in the definition, right? Those environment variables to add.
Yeah. So this is a data structure that contains information to start the process. We extend the environment variables with a variable az input with input path and az output with output path. So this is the same as writing an environment variable on a bash command line before the executable.
Okay.
So the environment variables are set only for that executable, not in your environment and anywhere else.
Oh.
And now And now we need some more complicated handlers. So this is just a .NET thing because we need to prepare a handler in a way that .NET expects us. But this is essentially whenever we get a line on standard out, we prefix std out and print it. The same with standard error. We add those handlers to the process information, and now here comes the sort of crazy part, because we'll be writing to input and output asynchronously at the same time in parallel. Because as I told you before, sockets are buffered. Once you write a bit to it, something needs to start reading from it. Same when you wait to read from it, something needs to start writing to it, and furthermore, because .NET is using server and client infrastructure, the server, you can ask it to wait for the client to connect to the socket by essentially meaning that the client will open the file or the file-like object. So we we do it asynchronously. We write a message to the input socket, we flash it, and that's all. For the output, we read it to the end of the stream, and both input socket and output socket will first wait for the client to connect to them and then start. And the third workflow will start the client. Now, I wasn't sure how to solve it, so I just added a little hack where we wait for the clients to create the sockets. Otherwise, the client will immediately start, and actually Haskell process is faster than the processes for the socket. I mean, the .NET part that creates the socket, and it needs some delay to ensure that those sockets exist for it to open. Otherwise, it will just complain that there was no socket. We start it. If it failed to start, we report an error, and then we sort of read its standard input and standard error and standard output, and then wait for it to exit. And that's pretty much it. Any questions?
So there is about this actually there are two things, right? One is input workflow and another one is output workflow.
Mm-hmm.
So I thought actually F# program is writing to the stream and Haskell is reading from it. But
no, I'm not writing to the screen. I'm writing to a socket.
Okay, you are writing to the socket, and Haskell program is reading from it. Is that
Yeah.
right? Okay. So we don't need here, right? So only Haskell needs to have that reading from the stream, right? We don't need F# doesn't need to have that.
Oh yeah, but Haskell, but I want to be able to get information back from the Haskell process.
Oh, okay.
So I'm not just so I want to be able to capture. So in a way, Haskell process will cause some side effects, and those side effects will mean writing to a socket, and I want to get that output.
Okay.
So in a way, I don't need that, because if the Haskell process was sort of performing only some side effects that I don't need to capture, then that would be fine. But again, we're trying to put it in an Azure Functions environment where the state of the instance is not necessarily guaranteed to persist. So ideally, I want to be able to capture all the results of the Haskell process and then put it in some sort of Azure storage or Azure queue or whatever I want, not on the machine itself. So I really need to be able to capture output from it.
Okay.
I mean, otherwise the Haskell executable would be just too pure to me. I mean, I will not get any output from it, right? So let's give it a spin and see what happens. Fingers crossed. So yeah, it works. So what actually happened? It created it. Okay, it's not creating them here. At this point, it's actually creating the input and output socket because it's waiting for them to. It's waiting for a client to connect. Then it's starting the client. This is standard error output from the Haskell executable. It connected, and we received hello monadic party. So if we look at the Haskell executable, so the main function is fairly simple. There is a hello function that works on byte strings. It unpacks whatever it received to a string, modifies the string, and packs it back. The reason why it's byte string is because sockets communicate via bytes. So I need to sort of pack and unpack them. And what's AZ in and AZ out? So AZ in is Azure input that works on the sort of looks for the AZ input environment variable that we specified before. And Azure input is it gets an environment variable specified as an argument. It traces it for debugging purposes. It creates a socket. So this creates a Unix domain socket working as a stream using default protocol to best of my knowledge, and connects to that socket and gets contents out of it. Now, get contents is a slightly modified function that's actually available in the network library. What it does, it loops some code that receives some chunks from the socket, and if the chunk is empty, because I believe we receive byte strings. So if it's empty, then we close the socket, and we return empty, because this is so I believe this is a lazy byte string. So we sort of close the socket and return a token that the byte string is empty. If not, we chunk it and we continue. So everybody, any questions about this bit? So how many of you work with byte strings in Haskell? So the problem with strings in Haskell is that string is by default just an array of char. They sort of improve that by having text data type where it's sort of length and an array. But sometimes you just need to work on the raw bytes, and that's what ByteString library gives you. And what lazy ByteString gives you is that sometimes you don't need to work. So Haskell is inherently lazy, but strict data structures work in a way that whenever you receive that data structure, it's fully evaluated. But sometimes you don't need, or rather you don't want to have a whole of that data type at this time. And so what lazy ByteString will do, how lazy ByteStrings work is that you can have some suspended computation. So I believe the moment you need to read more than this chunk, ByteString will actually start getting contents. So here where sort of laziness of Haskell is in a way useful, because even though the contents gives us a byte string, only when we need to sort of read more from it, Haskell will start evaluating it more. And I believe that's what unsafe interleave IO allows us to do. Although don't quote me on that, because I try to stay away from unsafe parts of Haskell as often as I can. Nevertheless, at the very end, we close the socket. And the library had the sort of get contents in the library will actually close the receiving parts of the socket. The thing is, we cannot do that because then we will, because the server part of .NET will also close the socket once it's not used, once it gets deallocated. So we cannot fully dispose of the socket from Haskell code. We need to be nice and sort of close our part of the socket and continue. And the input one is so that was the input one. The output one is slightly easier because actually sending stuff is easier in a way that you don't need to worry about when to stop, because you have all the data to begin with, so you can just shove it all to a socket and then deal with it. So that's what it does. It connects to a socket, sends everything, and then doesn't worry about it because the sort of .NET part will dispose of the socket later. How much time do we have? Yeah. So as you saw before, this works. Now let's put it together and actually make it run with Azure functions. So I'm just complaining. Oh. So this one is similar, but we do one sort of very cheap and dirty trick. For Cabal, we tell it that we want our bin path to be in bin debug net bin, which is sort of the default directory where the Azure. So this is the default directory the Azure Functions runtime will be, and we will run it, and we put it in the bin directory. So in this way, when we start the net standard runtime, it just needs to look in bin and look for our executable. Now, there is a potential danger because that's where all libraries of our runtime are being put. But I believe I called it Baz, and I don't expect to be any library called Baz in .NET at the moment. So I think we're fairly safe now. Obviously, this is not fit for real-life scenario because we will also need a mechanism to sort of put all these things together when we will be deploying to a server. But nevertheless, let's see how it works. The code is almost the same. The main difference is that we actually, so instead of having a main function that we saw before, we have a function that accepts a string. We will sort of have an HTTP request that will accept a person, and then we will send the name of the person to Haskell process. So the actual function is fairly simple. It's just Haskell run person name. So so if we do stack install to make sure that the latest Haskell executable is put in there, if we do .NET build, everything should be in place now. And if we do func host start, it will find a single function, and then if we send some data to it, is performed, we get the reply, hello monadic party. And once we inspect our logging data, that stuff is actually coming from from Haskell code. And now we need one more modification, because as I mentioned before, there is one issue with our input and output path, namely those names will be fixed per the temperature is fixed for each session, so we need to randomly generate input and output path. Was the easiest way to randomly generate a name? Anybody? So we'll just give it a GUID, or you. So I believe that's GUID, new GUID to string. That should be enough. Yep. So this way, so in a way this makes debugging horrible, because you generate a random name per every invocation, but it will actually allow to run multiple functions at the same time. There is a small caveat in the way that if you were to run thousands of those in a single machine, at one point you might run out of resources, but for all intents and purposes, it should not be the case, because the moment you start failing, I believe autoscaler will. Well, if we were to deploy it to Azure functions and put it in a consumption plan, I think it should be able to scale. And let's see it in action. So if I stop this. Still works, but here we can see that the name of an input and output sockets is randomly generated. So in a way we could in this case, when we will be processing multiple requests at the same time, each subsequent Haskell process will sort of expect different input. I mean, will look for input and output in different places. And any questions about that? Yeah, I'm about to finish.
So a function to create temp file that you could use instead of UIs.
Do you mean like? So yeah, if you, I believe most libraries that create new temp files will use some sort of GUID. This was the easiest one to do, but yeah, you can do that. You just need to be. So I did not want to create files because you ideally don't want to use any file I/O. In some cases you can. That would be another way of doing this. The problem with, but then the problem with file I/O is that you probably would have to use some sort of persisting file, because the nice thing about UK sockets is that nobody expects them to loiter around with the contents, whereas files you expect them to be more or less permanent. So you would have to connect to some sort of storage. When we will be working with Azure Container Instances, there is a way to connect them to a file storage, which I will show you. So you have some persistence in there.
So by default, you simply cannot create a file.
So in Azure Functions, I believe the runtime does not have permission to create a file. Definitely not in the directory. I think there is some scratch space you can access, but the problem with those is that so the reason why I'm not going to deploying these things is that and I believe I have not told you before, this is all running locally. I'm compiled to Mac, I'm running on Mac, everything is peachy, everything is fine. If I were to deploy it to, say, Windows, I would have to cross-compile it to Windows executable and run it there. And then the sort of Windows runtime behaves slightly differently because because Windows does not fully support Unix sockets. So ideally, I would want to run it on Linux instance. And the way you run it on Linux instance is you run it within a container. And for that, I believe you have access to write files. But again, you're not certain. I'm not sure what are the guarantees of it persisting. For Azure Container Instances, I think you can write a container, but ideally you want to attach some sort of external storage as a volume, the way you would with Docker. And yeah, that's enough for today. Any other questions?
Are there any plans for Azure to provide native support for Haskell?
Oh, the quick question is no. The longer question is that sort of. So they've been working on support for Python that works as a plugin. So in a way, that is a separate component that you can just plug into Azure Functions. So in a way, once they finish that, one could implement that sort of that plugin for Haskell. I sort of mentioned that yesterday. The problem with that solution is that the current API uses protobuf and gRPC, and Haskell does not have a good support for those. But maybe once they stabilize things, somebody, I mean,
Well, it will be easier because we will have to expose some API, right, for Python, so it will work.
yeah, so the IPA is already there, but it's not stable. So, and the worker is not fully documented. It's just a library in Python that you can look into, inspect, and it's written in sort of Microsoft style, so it's fairly big as a file. I mean, it's fairly big as a Python library. I've looked into that. I believe the biggest problem in there is that you need to implement a lot to see if it's actually working, which is a bit difficult if you don't know if your gRPC and protobuf support works out of the box. because there are multiple pain points that you can encounter, and they may derail your implementation. But I believe once they finish it, so say next year, we might have some sort of ability to run Haskell. The nice thing about the language worker is that by default it supports reloading. So say I don't know if you remember what I showed with CSX files, is that you don't need to recompile it. You just need to you can just edit your script file with your function. Click save, and the runtime should detect that and try reloading that function. So that becomes, I mean, it becomes for both CSX files, F# scripts on version 1, and sort of Python. You can just prototype it and sort of edit as you go. You don't need to restart the runtime, up to the point that there is an actual online editor that allows you to sort of prototype your code online. It's not ideal because you just type in the browser, so any more complex code might fail and break because you don't have any IntelliSense or the usual IDE support. But it's, especially for prototyping, is extremely useful. And also when you want to sort of demo some interesting functionality on the IDE you have, because writing, it takes you like less than 15 minutes to write it, deploy it, and see if it works or not. When it comes to more production workflows, I believe the biggest selling point is the fact that once you have everything in place, you can get a pay-per-use model. So things that would cost you, I mean, scenarios where you had to pay a monthly fee for your virtual machine now can sometimes be even free, because I mean on Azure, Microsoft provides some, I mean, say there is a free part that you don't need, there's some allowance, monthly allowance that you don't need to pay for. So if you can fit in that, that's fine. And yeah, so that's enough for today. Let's go for the lunch break. Okay, so yeah, what I showed you in the previous session is that as of now we can run Haskell on top of Azure Functions using a .NET wrapper and Unix domain sockets. And I also mentioned that there might be an easier way to run Haskell inside Azure Functions with all the niceties of having hot reloading, having it automatically managed by runtime, and consumption plan soon, because they're working on a language worker that's supposed to work as a plugin. And now we move to the last sort of thing that I wanted to show you, which are Azure Container Instances, which are essentially containers as a service. So what does it mean? So it's essentially the easiest way to run a container on the cloud I found so far. For most of them, it's essentially writing one command and then we'll boot up a container. They offer both Windows and Linux containers. Azure, aside from providing, from allowing you to run containers from within Docker registry and from within your own, a Docker registry that you host on your own, also have a hosted offering. As far as I remember, the container registry itself is free, but you pay for storage the same way you would pay for Azure storage, which is fairly cheap. I believe I don't remember the numbers on top of my head. We can check them later. And what's important, they also have an ability to connect volumes, but they're working for Linux containers at the moment.
You mean the easiest on Azure or in general?
Google, Kubernetes on Google is pretty nice and smooth as well, but then but for that one you actually need to specify your the layout of your cluster. This one is perfect if you just have a container that you want to run every now and again. Okay, so I'm just gonna do the nasty thing and switch to their documentation. So everything I'll be doing now will be within their Azure portal. So because you actually need an Azure account. So there is a free trial. If you want to follow me, I encourage you to sort of start a free account and then go from there. I don't remember if they require a credit card or not to register, but if they require a credit card, they should notify you before they charge you. If not, you can just follow what I'm doing, and if they charge me, then that's exactly on me. They also, everything I'll be doing now is essentially running within a Linux instance with Azure command line tool installed. So everything I'll be doing now, you can download. There is a Azure CLI, which is a package available for Windows, Mac, and Linux. You can download and run it on your own machine. The main difference is that the subscription that I have set up on my machine is my work one, and I don't want to go through the trouble of adding another one and accidentally changing it, because I believe my boss will not be too happy about me doing some demo stuff on that account. So once you log in, you can actually open something called Cloud Shell, which is essentially a command line interface that's running on top of a virtual machine. We'll go for Linux. Now, okay, let's try create an Azure subscription. Start for free. And will it allow me to go for free one now or not? Yeah. This will be interesting. Phone. I probably should not do that, show that. What? Okay. Bear with me, there are some unforeseen technical difficulties. This will be interesting. Okay. Wow. Okay, so yeah, for those of you that have seen Microsoft people use Chrome during their presentation, I'll have to actually use my production account to do that. Okay. Okay. So yeah, this works. Don't tell my boss I did it. So essentially, yeah. So this is an online shell that contains the same functionality as you would do if you were to log in, if you were to use Azure CLI on your own laptop. So it gives you, I mean, this thing just gives you. It's a virtual machine connected to Azure Storage. When you boot it up, it'll tell you which resource group it started it and which storage account it is in. Now, if we switch back to the documentation contains a quick start that uses Azure Portal that I encourage you to use. And the nice thing about using this documentation, this one shows you how to use how to sort of use the GUI. The nice thing about this one is that you can actually, and there is a small button here, and all these documentations that once you click it, will allow you to log in, and you'll be able to use Azure Shell from within the documentation, which is pretty. I mean, Microsoft has been working recently really hard to make sure that Which Azure account am I in now? This one. Okay, so now I'm connected in Azure Shell within my documentation, and I can actually run these commands the same way I would run them in the using the CLI. Now we will not create. So I'll change the name of the group. So that's and the location will be West Europe. So it created the resource group. Now we need to create the container itself, and the way you create the container is you give it a name, you give it an image. So this one will download the image Microsoft AC Hello World from Docker Hub. You give it a DNS label, and you specify a list of ports that the container will be able to expose. So if we copy it, if we paste it, no, it's not working. And we need to change the name of the group. Oh, labels are already taken. So it succeeded. So we created the container with this image. It has we requested 1 CPU and 1.5 gigabyte of RAM, and it's still in pending. It exports port 80, and it will have this fully qualified domain name. Now, it also tells you IP. The only problem is that, as far as I remember, container IPs can get recycled at times. So you should not trust the IP. You should trust the fully qualified domain name. And now let's query the status of the container. So that's resource group. That was NParty. How did I call it? Monolithic party. So it succeeded provisioning. So if we go to Azure containers, I believe. Different link. Region. There's also a region in there. So this is the container we just provisioned. Is up in there. And so now we can the only thing that you need to remember is that it's just a container. This product is simpler than Kubernetes, so it will not so if you push a new image, it will not automatically pull it. You will have to tear down the instance and start a new one for it to download the image. There are some offerings on top of Azure that can run a container, and it will be able to update it every time you push it. But this one is not. Is not smart enough to do that. You can actually you can script it. I think you can set it up via continuous integration, continuous deployment pipeline, so that it will delete an existing container and start a new one. But I will not show it to you how to do. I will not show it to you how to do it today. And let's see what can we do with the container. We can also attach to see to see the log of, I believe, just connect via standard. Just connect to the container to see its std out. So that's. So here you can see the logs from the container in real time. So the reason why it's complaining is, I believe, is because my browser, because I opened the website in the browser, Mozilla is trying to download the favicon for the website and failing. That's why it keeps getting 404, because the container only contains a static website. And that's more or less all you can do with a container. So additional things are available in the documentation. This product actually reached general availability, meaning that it's stable and they will support you when you use it last month. So it's fairly new. And one additional thing which I wanted to show you is how to configure a data volume. So this is slightly more complicated than the demo I showed you earlier. So I'll not run it because it might go horribly wrong. But essentially, you can create a file share, which is something similar to a network drive, and you can connect it to the container as a volume. This way, whenever the container uses files in there, they will persist it between instances of the container. And now this example is fairly complex because it sort of does it in a nice DevOps way. When you create new storage account at random, you create a file share. You use the tools to download the credentials, and the important part is that you can only mount the volume whenever you create a container, pretty similar to the way you store the Docker container. So if you want to connect it afterwards, you need to and sort of keep the same label, keep the same DNS label. You need to tear it down and start it again. So I think it's the only actual danger which I encountered with running with this product is that somebody can sort of steal your DNS label, and I have not found a good way around that. But aside from that, it's pretty fine. So if you use some sort of random name for your container, you should be fine. If you need anything more, actually, if you need anything more complex, then you probably should be using your own. I mean, either the DNS provided on Azure or use your own DNS to handle it. And let me just clean after myself here. So do you have any further questions? Yep.
I don't really immediately see the difference between like this what you showed now and like the regular container engine, for example, from Google. So what is it that really makes this like serverless as opposed to like just like containers as a service or something like that?
So okay, so Google's. Are we talking about which product offered by Google are we talking about?
You have like Google Container Engine or something like that?
So I believe, okay, so Google Container Engine I believe will be fairly similar to this one. Because I think at the moment, most cloud providers give you the sort of, let me just delete that and I'll continue. Okay, this will work. So, so at the moment, both Amazon, Google, and Azure, and probably other cloud providers will offer you some sort of way to run just a container. I'm using this one because, as I said, I use Azure in my day-to-day work. If you're using Google Container Engine or Amazon, I forgot the Amazon one. Then and you're happy with that, then you're perfectly fine. I just wanted to showcase the people that might not know the sort of bring your own container serverless model. So it's serverless in a way that you have no controls. So aside from specifying what sorts of resources your container has, you have no control over it. I mean, in container instances, you might not even have a control over what or how often your IP is. Gets refreshed, or how often, or whether you will. So you should not rely on that. You should rely on the DNS label. Some other things. Oh, one thing I haven't shown here. When you start a container, you need to specify what sorts of restart policy you want it to do. So for ACA, there are 3 restart policies. First one, which is essentially keep it alive as often as possible. If it fails, or if it finishes or fails, the ACA will restart it. Then there's another one where you sort of run it once and never restart it. So this is good for one-off workloads. And the third one will run it and restart it only on failure. So as long as it detects that everything went fine, it finishes it. So in a way, this is serverless because it allows you to perform some sort of workload or some sort of work you want to do once or say once, and you don't need to provision a virtual machine. You don't need to worry about it. You don't need to do anything. You just write a single line of code or a script that gets either scheduled or run once, and then everything is done. So that's the sort of the other end of serverless spectrum, when you don't worry about the virtual machines, provisioning, or anything. And I hope that answered your question.
Yeah, more or less. I guess the lines are getting quite vague between all of the different offerings, like platform as a service.
Yes, yeah, in a way. I mean, yeah, I can easily change this to bring your own files by starting an Azure Functions runtime within that container and mounting the directory where the files should be on Azure file storage, and then I can sort of I can interact with it. So it gets really fuzzy, especially now that Microsoft is working on Azure Functions for Linux, which run themselves in the container. So it gets really blurry, and quite often Microsoft side. So when you start working with Azure, you notice that there are multiple products that sort of overlap quite a lot, and it's difficult to figure out which product you should use at this point in time, mostly because switching back to a different product midway through a project can be really painful. And the last thing you want is sort of realizing that you cannot finish your project this way, you need to do it in another way. That's one of the reasons why there's a lot of consulting companies built around Azure that help people build stuff. I believe Google is sort of better in a way that has more oriented products. Hi. And but yeah, I mean, everything essentially comes down to sort of trying to cater whatever they do. I mean, these are two extreme ones. I think, if I remember correctly, when it comes just to building microservices, Microsoft had like 5 different ways of doing them, depending on how much control you wanted or not. One interesting thing people do with this is that they started doing recently, and I haven't played with it, is that you can start a Kubernetes cluster on top of Microsoft Azure, and then you can add nodes to it via ACI. So you can easily add, you can programmatically and easily spin more nodes, so the cluster will rebalance itself, and then simply turn them down. So I know that they're working on more tighter integration between it and Kubernetes, and I think that stuff is getting pushed to upstream, but I'm not a Kubernetes expert, and I definitely don't have Kubernetes experience, because the workloads I've been working on we're looking into moving to Kubernetes, but we realized that it will make our life easier in some places, but it will make our life more difficult in other places, and we don't need to make that move yet. I know that I know of some companies that they're so interested in Kubernetes that they go into some sort of interesting choice of technology simply to be able to build on top of Kubernetes. And from my perspective, I can understand them, because it's a nice shiny thing that looks amazing. But I'm stuck with this. So, any further questions? Okay. I do apologize for not making this session longer, but I cannot show and I'm reluctant to play with my company's account. So yeah. Yeah. For this one? Oh, in Haskell? No. So we didn't run anything in production because, well, mostly because I'm the only person in the company that would understand the code. So that's main reason. It took enough of convincing to. So it's interesting thing because my boss wants to use F#, but at the same time, the company is using technology stuff Microsoft offers in a way that F# does not support it. And if we were to throw in Haskell in the mix, then there will be even less that they could do with Haskell. So we were just looking at how we can take those things that we know Haskell would work with and see how difficult it would be to move them to Haskell. And I showed you the results of experimenting with that. Aside from that, we've been trying to sort of steer away from Python as much as possible, but every now and again we need to run some Python code simply because it's easier to experiment with and it's easier to prototype. Quite often we need to use some sort of library or some sort of algorithm that's already there implemented in Python, and we would have to write it ourselves in Haskell or in F#, and that's how it is. Also, some things that we do are really difficult to express on type level, I mean in terms of types, and quite often you would just end up with really, either you would have to stick everything in I/O or end up with some sort of simple type, simply because it's difficult to use type machinery to help you. The stuff that's the sort of, in my experience, working with strongly typed language is best when it comes to libraries, because quite often so you work with documentation, but types help a lot because they show you how you can call library functions and you don't need to guess or run it beforehand. Yeah, that's pretty much the short version. The long version would be too long.
Yeah,
Yeah.
it's hard to find, justify it. When you're the only one in Haskell developers, it's really hard to justify it.
Yeah, I mean there are some new things that I think justifying would be interesting. I mean, especially if you go to greenfield project. But the problem, at least in my case, the problem boils down to the fact that we already have libraries and parts that are so easy to interact with Python and .NET that simply redoing them in Haskell would be a bit of a waste. Translating to a microservice architecture helps because you just speak JSON or some sort of RPC mechanism, and that makes it easier. Bus factor is always there, and you cannot get rid of it. But at the same time, I think it was mentioned yesterday in the beginner's talk that the most important metric is whether your client pays you. But at the same time, you can look at it in a slightly different way. It's like the most important metric is your time to market, as in how fast can you finish your product so that you can sell it and your client pays it for you. And you cannot really be the functional language there. Like doing writing a product both in Haskell and in F# tends to be way faster than doing it in C#. I mean, there are some IDEs that help you, and they give you an illusion of productivity. But quite often, the moment you just want to use the moment you start modeling your business logic, then nothing beats summon product types or I mean, you can. Well, it's. So it looks like OCaml, and I think it used to have an OCaml.
It was inspired heavily by
Yeah, but it used to be that you could actually, there was a subset of OCaml that would work in F# and vice versa. There was like a OCaml fallback mode. The reason why F# is sort of great is that starting with Visual Studio 2017, F# development tools are installed by default. So every developer that has a Visual Studio 2017 installed has F# installed, and they can play with it. It's an open source language because there are some people from Microsoft working on it, but it's actually run by F# Foundation, and there is a ton of libraries from .NET scene that you can interact with. It's different than Haskell. The moment you try to write Haskell and F# on F# and Haskell, it is really weird because F# is strict, Haskell is lazy, but knowing one helps. Working with one, I mean, there's a lot of transferable skills between them. And yeah, I mean, I've seen some F# people attend Haskell talks. I have not seen any Haskell people attend F# talks. So, but nevertheless, I mean, the community is smaller than Haskell, though. Like, if you look at, I think worldwide there are more Haskellers than F#ers. I attended F# exchange in London. It was like 40, 60 people. And if somebody were to plant a bomb in that building, the language would disappear overnight. I think with Haskellers it's more like, you would have to kill like, what, 100 people now, not just 50. I mean, yeah.
But F# has support from Microsoft. So
Yeah, I mean, yes, they do. It's not as good support as C# receives, but yes, there is a lot of support from Microsoft. They're working heavily. They're actively making it better. It's not abandoned. So that's even though sometimes it might seem so. You can get a person on Twitter ranting about it that is getting abandoned. It's not. It's actually being actively developed, and people are making it better. Any other questions? Okay.
thanks.
You're welcome.